now we're going to talk just about transforming functions, and we've done this. We did this a little bit when in Unit 1 when we were talking about absolute value functions, and we did it in Section 2.1 just a tiny bit when we wrote our new equation. So it's really helpful, especially when you're going backwards or trying to figure out what a graph looks like, to know the very simple transformations and then the basic look of a function. Now, right now, we're just going to talk about how they show up in an equation, and then next time we'll talk about what it looks like on a particular function, okay, the exact things that it looks like. So the first thing we're going to learn about is a horizontal shift, and like I said, we talked about this a little bit. We know that if it's x plus k, then it's going to do the opposite sign of what is there. If it's x plus k, then you're moving to the left, and if it's x minus k, you're actually moving to the right. So it doesn't matter what the function is. That's why it's just f. It's not an x squared like we have in this graph up here on our screen. It is just f of x. So no matter what it is, no matter what the function is, if it's on the inside and it's added, it's moving to the left. So for example, in part A, this is a movement left 3. In part B, that is a movement right 2. And that's it. When you see the transformation outside of your function, after the function, right? And that's important. It does have to be after. It has to be added or subtracted. It's not multiplied. But if you see the transformation after the function and it's added or subtracted, that is a vertical shift. So that means it's either moving up or down. So in this case, in example 2, that plus 5 is moving it up 5, because when it's outside, it's not going to do anything other than what you would expect it to do. In this case, it's moving it up. For part B, it's a minus 3. That's what this is right here. So this is moving it down 3. We also have reflections. If it's a reflection about the y-axis, that means that your function would be going from something like this to the other side. And maybe it doesn't, maybe it's not a parabola, right? Maybe it's cubic. So that means it's going like this, and it's flipping over the y-axis, so it's going to look like this now. Okay, that is what a reflection about the y-axis looks like, and it goes inside. That means it's f of negative something. Okay, when that negative is on the x, it goes inside and it's a reflection about the y-axis. A reflection about the x-axis is on the outside, and it looks more like what we're used to. Now, if I had that same graph, let's say I started with my cubic function again, that looks like this. This is what a cubic function looks like. If I reflected that about the x-axis, it would go from the top right to the bottom right. So it would flip, and it would go like this now. It's going down on that side and up on the left. So look at those colors and make sure you're seeing which one's which graph. Okay, hopefully you're listening to this. That's really helpful. But that, to indicate a reflection about the x-axis, the negative is on the outside. So when we have something like this, there's not a whole lot we can do to it. The negative on the outside is a reflection in or about the x-axis. And this is a reflection in the y-axis. Now, while before I didn't say, I just said up, down, left, or right. Those are very simple terms. When you're talking about a reflection, you do have to say it's a reflection and what axis it is reflected about. If you don't include all of that, then you're not actually describing it properly, because just saying a reflection is not enough information. The next thing that can happen is things can get thinner and wider. Okay, so instead of, if I have, say I have a parabola, standard, looks like this. And then it gets stretched out. So now it's stretched up. Okay, that's a vertical stretch. That's a vertical stretch. And then if it goes wider, like that, that's a vertical shrink. And a horizontal stretch or shrink does the exact opposite thing. And the indicators are similar to your reflections. So we're going to have a vertical dilation if it's on the outside, and a horizontal dilation if it's on the inside. So a vertical dilation, and so we're not going to worry about stretch or shrink as much, although those are terms that you might see somewhere. We're really just worried about, is it vertical or horizontal? And the answer is based on where the number is. So you see that 2, that's outside. So this is a vertical dilation by 2. Now your horizontals, those are the ones that are inside, right? Just like before. So this is a horizontal and you still have to say what it's by. And the weird part of this is that we're going to take that 2/3 and we're going to flip it. So it's not by 2/3 anymore, it's by 3/2. So you do have to flip that number to actually describe what's happening accurately. Okay, if you want to explore that more, look at what's happening on the graph when you do your practice. Now, we will have combinations of transformations. So that's what's happening here in example 5. So we have a few things going on, right? We have this negative in front. That's a reflection. Reflection in the x-axis. Then we have this up 4. I'm sorry, that's not up 4. We have this plus 4. The plus 4 is actually a movement to the left 4 because it's on the inside, so we do the opposite sign of what's there. Then we have this minus 3. That was supposed to change colors. Which is moving down 3. Okay, so whenever you have a combination of things, you have to describe all of those things. If you don't describe all of them and you miss one, that's when we're going to have to start taking off points because you don't know what's happening to the graph. Let's do part B. We have a negative here. That negative is a reflection and the x-axis again, because that negative is on the outside. Now, you should notice very, very clearly, right? I purposefully did not put the negative and the 3 together. They are 2 different transformations. The 3 is a vertical dilation. And it only refers to the positive number that's there. The reason it only refers to the positive number that's there is because the reflection is already taken care of by saying it's a reflection, right? This is not a vertical dilation by negative 3. That's not how we describe it. You have the negative for the reflection and then the vertical dilation by 3. That is the 3. Okay, so those are 2 separate transformations. Don't put them together. Then we have a plus 2. The plus 2 is just a movement up 2 because it's on the outside. And that's it.